Thank you for the kind introduction. So, as you just learned, I'm a member of the Go team, but today I'm actually talking about some earlier work I did at Google, or something related to it, at least, namely configuration languages. So for those of you who don't know what that means, so basically a configuration language is any kind of language that allows making it easier to deal with very large amounts of data. So data like JSON specifications or protobufs or whatever. So I'm going to introduce a new approach to this called Q, and I'm going to also explain to you why this relates to Go and how it interacts with Go in various ways. So in my early days at Google, I started working on this new project called Bork that you might have heard of. So for those of you who don't know, Kubernetes is a spin-off of Bork. It's basically the open source version of it. And both Bork and Kubernetes allow you to distribute workloads across a pool of machines. So you can imagine if you do this at Google, you have like these gigantic services that just telling which machine and which server should run and talk to which other server gets pretty daunting. And we learned earlier, we tried code generating configurations. That's generally a bad idea. So we wanted to do something declarative. And that's how BCL got started. So I developed this as part of the Bork project together with Robert Griesemer, actually. So it's still one of the largest languages at Google, actually. It's larger than Go, larger than Python, but it has a lot of problems. And it's one of the reasons we didn't open source it. But there's actually many spin-offs of this language that now are open source. But either these languages, they're too restrictive, they identify the problems and removed it, or they just maybe improve some marginal things, but they copied the essential mistakes. And this basically results in too much complexity, but really the big promise of a declarative language is automation. And like the big mistake in BCL, as I'll show later, is something that actually makes automation nearly impossible. And so this holds for all these offshoot languages as well. So what could we actually do better? So there's actually a whole bunch of things we can do better, but I want to focus on two things today. So the first thing is, like most of these languages have poor or no validation, or type checking, if you will. So this definitely holds true for BCL. It holds true for many of the spin-off languages. There are some languages that try to attack this within Google, and also I think COIL outside of Google, but essentially the validation is either non-existent or quite lacking. And there's actually quite an oversight. Like if you're dealing with large amounts of code, everybody would say use a compiled language, or at least use a type check language, right? Nobody would argue to not do that for a large code base. So why don't you then do that for a large amount of data as well that you try to manage in code? So the other problem is inheritance. So it actually turns out that inheritance is one of the biggest sources of complexity in these languages. And inheritance can mean many different things. So with that, I also mean overrides and things like that. But it actually causes a lot of complexity. And more importantly, it prevents automation. But also, if you think about what most configuration languages focus on, they focus on reducing boilerplate. Clearly not type checking. They focus on reducing boilerplate, but if you do that, you have a trade-off. On the one hand, we want to reduce the boilerplate, make it easier to manage the configurations. On the other hand, that introduces complexity, because now values can come from multiple places. And is that trade-off worth it or not? And with inheritance, I argue that very often it's not worth it. It becomes too complex, too hard to understand. It's still a lot easier than having code-generating configurations. In many cases, it depends on the application, but very often this is the case. So is there an alternative? So in my heydays, before I worked at Google, I worked in the Valley at a company that does computational linguistics. And if you think about it, like in linguistics, you're basically dealing with grammars, like for the English grammar, not a computer programming language. And I can tell you these grammars are vastly more complex than a grammar for Go, for example, or even C++. And also you have all the words of the English language are encoded in this declarative way, right? So basically, you have these JSON-like or sort of data structures that encode the entire English language, the entire lexicon, but also domain-specific knowledge, and it's all encoded in the same formalism. So this is basically a gigantic configuration, and yet nobody had any problems managing this. Of course, there are some issues. If you're doing it at that scale, you have, but you're able to make fantastic automation tools. You know, like non-computer scientists could actually manage this data, right? So this really seems like they're onto something. So basically, the formalism they were using was graph unification. So this is invented by some of the same people that invented Prolog, but it's much more. It clearly came later. Right? It's 30 years old, but it's quite a nice formalism. So why? So one of the essential properties of it is that if you're going to combine data using this approach, the operations on it are associative, commutative, and idempotent. So like addition and multiplication are. So if you look at one of the spin-offs of BCL, so they mention on their website that inheritance is almost these properties if you don't do this, this, and this, which in practice is not very useful. If you want to have automation, you want to have guaranteed that you always have these properties. So that kind of doesn't work in practice. So it's important to have these properties. So what does this give you? So another big property of this formalism is that it puts type checking first, right? So the first thing is it constrains your data. It tells you, for example, in linguistics it's quite important. If you have a noun and a verb, right, they have to have agreement on person and plurality and all this kind of stuff. So they have cross-relational constraints. So it's constraint checking first, but as it turns out, constraints combined with its properties can also reduce boilerplate. But it's a very different approach. So the best way to demonstrate what this can do is by a live demo. But before I do that, I first have to make some of these concepts a little bit more concrete. And so the first thing to realize, this is a little bit a novel thing for if you compare it to programming languages, is that types are values. They're the same thing. So what does that mean? So let's look first in how you would represent JSON in Q. So Q is a superset of JSON, so basically the only thing you get here is that you have some syntactic sugar that makes it easier to write JSON, but it's pretty straightforward, right? Like you see the quotes on the left hand are optional. You have you know, some nicer way to write numbers and things like that. You don't need the commas anymore. That's borrowed from a Go trick, very clever trick where they removed the semicolon. But as I said, you also can represent types. So let's see, how would you represent a Go struct in Q? So on the right-hand side, we see the Go struct. On the left-hand side, we see it in Q. So we see now, I've generalized this. Before I saw a definition of Moscow. Now I'm saying any town or place. So it can have a name, right, which is any string. It has a population, which is an integer. And it has a capital. It's either capital or not, so that's a Boolean. And that's how I represent that. So as you can see, it looks very similar to the way I wrote JSON. So I think you can see where this is going, maybe. So what you can also do in Q is something like that. So what if I want to specify something in between? So I want to define what is a large capital. So I can say, well, it can still have any name. Capital must be true by definition. But the population, I'm just making something up. I think it's large if it's larger than 5 million. So this brings us to the next concept. So this approach is like very rigid. So every value that you have is ordered in a lattice. So you don't really need to know to use this language to understand what it is. But for those of you that care, lattice is basically a partial order where for every two values, if you combine them, there is a single greatest lower bound. And basically what that means, if you apply the operation on any two values, you will always get the same result, loosely spoken. And also I can order anything. So it doesn't matter if it's a configuration or a leaf value, everything is partially ordered. So what does that mean for these concrete examples I showed before? So at the top here, so we're going from for least specific to more specific to the bottom. So at the top you see our municipality, right, which is our, let's say our Go type, any value. Then an instance of that, if you will, is the large capital, which is a type of municipality. And then an instance of that is our Moscow struct, right, which is more the JSON value. And then it cannot get more specific than that. So this also works with values. So you have, it's a strongly typed language. So you have, for example, a number, which can be an int or a float. So I can put bounds on numbers. So smaller than 5 and greater than 3 are both subsets of numbers. I can combine bounds, right, to define ranges. And then specific numbers can be instances of these ranges. The same thing holds for strings. So a string can be any string, but I can define regular expressions. And then concrete strings can either match those regular expressions or not. And if they match, they're an instance of these regular expressions. That's how that's defined. And a key property here is to realize that if I say something is 1, it's 1. I can never change that. And to a lot of computer scientists, that seems weird, right? But to most, let's say, normal people, this is actually quite natural. So let's say I define a cat somewhere with behavior and properties in some code. Then I create an instance of that with inheritance, and I override the properties for it to be a dog, right? Like, to a computer scientist, that might sound like, yeah, you can do that. To most humans, it would be like, well, you've said it was a cat first, and now it's a dog. Like, what is it? It doesn't make any sense. So in a normal way of ordering a hierarchy, you go from less specific to more specific, right? And you introduce a new category like animal or mammal above that. So here it's the same thing. You cannot override what you already have. So if any of you have experience with configuration languages, you know that this is the key, inheritance is the key to reduce boilerplate. And now I'm saying you cannot use it anymore. So what gives? So as I already alluded to before, constraints actually also reduce boilerplate. So they are validators, they're both type checking and a mechanism to reduce boilerplate at the same time. And the best way is, again, to show that in a demo. I will do that soon, but a few more properties of the language. So one thing, a lot of people complain about curly braces, that's why they use YAML. So in Q, what I can do, I can represent any JSON file as a path value combination, right? So if you want, you can eliminate all curly braces. But the grammar, it's still not a positional language, right? So having a language like YAML is very not conducive, let's say, for code generation. This language is very much like Go, very much focused on code generation. We want machines to do most of the work. And if you have a language like Python or YAML, like a lot of that becomes extremely complicated. So we want to retain that property, but I still wanted to reduce the curly braces. This is actually a trick I took from HCL, which nice invention. So then we have sum types, or enums, however you want to call it. We have default values, so you can say this has to be a number, but if you don't specify anything, it can be 1. We have arithmetic, string interpolation, Swift style, and Python style list comprehensions. So, all nice and well. This looks a little bit eerie. This is a picture of my home country. It looks much nicer in reality, but I think I played around with the filters a little bit too much. But anyway, it's a nice place to visit. Anyway, so all of this sounds very nice theoretically, right? But this has to work in practice, otherwise it's quite useless. And that actually sounds maybe easier than it is. So the problem is, if you have your leaf configurations, or let's say you have your YAML or JSON configurations right now, you actually don't have the types, right? So somebody needs to define a schema. And defining a schema is very cumbersome, but keeping it up to date is even worse, right? So I think it's, I have to look now, Kurt Vonnegut, if I pronounce it correctly, said that one of the flaws another flaw in human character is that everybody wants to build, but nobody wants to do maintenance, right? So this is actually a real problem for this kind of language. And now, what you've all been waiting for, this is where Go comes in. So if you think about it, Q is a superset of JSON, so it basically adheres to the JSON model of representing data for all its good and its bad. But the good thing about it is that most of the, let's say, like big projects in Go, where you, or even that are around for like cloud, for Kubernetes, Istio, they use Go and they use JSON as their means of configuration, right? So sure, Kubernetes also supports YAML, right? But it's all JSON under the hood. Now also in Go, JSON is quite standardized, right? The way you use JSON in Go is like everybody uses encoding JSON or maps on it usually one way or the other. So that basically means I can look at the Go code and pretty much know what all these types will be that Kubernetes uses, right? So that means the Go code is my source of truth of what is a Q schema, right? And Go also has very good tooling, as you know, for analyzing Go code. So I can basically derive the Q schemas from Go for free. And this is what I'll be showing. So I have like 2,000 lines of YAML of Kubernetes configuration, tons of microservices. I'm then going to derive the Q schema from Kubernetes without any additional input, right? This is purely as is. Then I'm going to combine that into validated Q. And then I'm converting that back to YAML and send it to Kubernetes. Okay, so now it gets very exciting, for me at least. So let's hope the demo gods are nice today. All right, so here we have some YAML. So, let's make this bigger. So if I look at the current directory, so you can see there's a whole bunch of YAML files, and they all pretty much in one way, shape, or form look like this. So I have my service, I have my deployment, and this is like what you would expect from Kubernetes. So this is all anonymized, if you will, but this is based on a real service. So let's see. So the first thing I need to do now is I need to, I want to make this an option to make this not necessary actually, but not that far yet. So I first need to convert this to Q. Of course, I don't want to do this by hand, so, and we love automation, right? So I'm going to say I want to import this. And let's see what it says. So now, first it complains. So what happens here is I'm actually importing many files. And the way Q works, because of its order independence, it says, I'm not going to let you do imports and all that stuff for things that are all the same model. You just have to define a namespace, and then I'm going to dump all these configurations into the same configuration by unifying them all together. So I have to define a package name. Okay, fine. I'll do that. Okay, next problem. Again, this can all be automated. Haven't gotten to this yet. But the next problem is, if you look again at the YAML definitions here, like they're all top-level objects, right? And what I'm doing now, I'm unifying it all at the top level. So that means that even the kinds are different, right? So it will clash, and it says like, well, here you have a deployment, here you have a service that doesn't match. So I need to put each of these objects in a tree somehow, right? To be able to identify them. So for that, I'm defining the path. So I'm using string interpolation for that. I'm being very careful with my parentheses here. So the first thing, I want to sort them by kind. So if you see here, kind is a capitalized, the kind names are capitalized, which I don't like. So there is a standard library in Q, which is actually generated from the Go standard library. I like generation. I think you might get this by now. And then we say kind. And then the next thing, the next part of the path, so the next entry in the tree is the actual name of the service or deployment, right? So, or whatever it is. So that is called metadata, not MAME. That's not nice, name. Now it complains because I already generated some, so I have to override it. And of course, this is a demo. To camel. Oh, for Christ's sake. Yes, thank you. There we go. So this worked. So let's look at, for example, what it generated. So here you see Q, right? It's the same YAML definition, but then in Q. But there is one thing I don't like. I scroll to this, So if we look at the config map that it generated here, let's go back here, make this a little bit bigger. So you see that I have here for data, I have this large blob of YAML still in there. So if we look at the original YAML, it kind of looks like it's recursive YAML here, right? The editor will syntax highlight it properly and all that stuff. But actually it's not, right? Like if you know YAML, like this thing basically means it's an inline string. So we don't like that, because basically what it means is if I make an error in this YAML configuration here, I won't find out until it's already launched and off to Kubernetes, right? So this is actually quite horrendous. So we want to typecheck this too. So let's go back here. So for that we have an option. And now my editor is gone. Terminal. Well, that's quite brilliant. Okay, VS Code is letting me down. I said, there's always something that goes wrong in a demo like this. So I have to quit VS Code, I guess. This is not great. Let's hope, yes, I have my editor back, my terminal back, that's great. Maybe that was the problem. So anyway, so now I'm adding the -r option, and what that says, I'm going to look at any strings recursively that look like structured YAML, right, like complex YAML or JSON, and I'm going to convert that too. And of course, now it's not working anymore. Thank you, VS Code. So, yes. I'm in the wrong directory now. Tutorial, Kubernetes, demo, services. There we go, and it is changed now to be structured queue, and it has this little addition here where I convert that queue into YAML. Okay, so now we run qvet. At least this works, that's great. So now we're going back to this little thing here. So I said before, right, like I promised type checking, basically. And if I take one field where very clearly this should be a string, right, and I run vet now, it doesn't complain, right? So this is not great. So now we need to actually define the templates. So luckily I have this in my history. So what I'm doing now, there's a qget-go that basically says import Go definitions from this Go package, and the -v basically says, you know, like show what you're doing. For this, I need to have an internet connection, and it works. Fantastic. So the things that I care about is, it's a little bit too small here, but basically the core one, like here, and extensions, they all have no errors. And these errors are related to, you know, like I cannot convert functions and interfaces, but that's fine, right? We don't generally care about it. Another thing that we do care about is this. So if something implements the JSON marshaller interface, or, you know, unmarshaller, that basically means I don't know what queue it represents, right? Because it's represented in code. But luckily, there are only very few types where this is an issue, right? So like these definitions are gigantic. If you care, this is how it looks like. So 18 directories, 44 files. I mean, it's a huge amount of definitions I've generated now. Okay, so let's run our vet again. Right, so now I have to say that these services and deployments are actually of this kind. So I do. So what I'm doing now is at the top level of my directory, I'm creating a new file where I'm saying like these definitions have to apply to everything in the subdirectories. So I have to say package cube. So then I'm gonna, let's copy this thing. Not confident enough, I can type that without an error. So we import this package, then I'm importing core as well. And now I'm basically, so now it gets a little bit funky Q syntax. So I'm saying that any service, so this is the notation for any service, is basically a core, no wait, a V1 service. Don't complete that. And I'm basically saying that any deployment, yeah, doesn't matter, is a V1 beta deployment. Yep, let's save that, yes. Okay, so now let's run our fat check, and it complains. So what does it complain about? Let's go there. So it says that API version needs to be a string, and the offending value is here, which is correct, because I changed that. So let's change that back. And now we have, should have a correct file again. So if you look at this file again, so if you look at this file, so there's still a lot of things that I can still check more. So if you looked at the Kubernetes, you saw that a lot of the fields were optional, so it doesn't really constrain me much. So I want to define more types, and I'm going to base that on this file. So now I'm going to open the original. Yep, here we are. Get the terminal less. So I'm going to say, I'm going to base my templates, my constraints, on one example template. This is also something I could automate. There's a known algorithm for this in the community. It's already like 15 years old by now, but haven't done that yet. So basically saying again, this applies to any service and deployment. So now I'm going to say, okay, this bartender, of course, is specific, so I need to generalize that by saying this binds to the name of the fields of the entity. So I'm saying a port can be an integer, target port's actually optional. I want to apply this to every port. TCP, everything is TCP, I know that, but let's also allow UDP. So client is a nice name to have as default, so why not? But it can really be any string. So then this front end is the directory name. So I know that every service should have this. I'm going to require this in my organization. I should always have a component label. So I'm just going to define that as such. I have to change this one too. And what I'm also going to require is that I'm saying that any label that I have is also a selector, so I can do that. Labels, anything else. So this is specific, so I'm going to remove this. The image varies, the container port varies, the arguments vary. So I think we now have a nice generalization of what every service that I have should look like. Okay, so let's pop back the editor, and it's still there, that's fantastic. So let's run that again. And now it complains. So this is nice. So I'm saying here replicas is always to be 1, but I actually want a default of 1. So this should be good. So what else? Okay, so this is the problem I was waiting for. So it turns out that some of the configurations I had actually did not conform to the standard that I wanted to do. So what I'm going to do now, I have to speed it up a little bit, I see. So I'm going to make, I'm going to change this. So I have this command. I'm basically going to say I'm now going to create a component entry in every subdirectory that I can use in my configurations. That's there. So just to give you an idea that this is really the problem, I can make it an optional field. And then this check passes, right? But that's not what I want to do. So I'm now going to say here, I have a component entry at the top level. It's a string. And I have to change this. Yep. And now it works again. So I've now fixed my configurations to conform to the standard I've put in myself. So that's nice. But now what you see at this top level, I have now all this sort of constraints, like the requirements that I have for my configurations. But if you go to like this little file here, you see that I'm having a lot of these files repeated. So remember that before I said that constraints are actually also able to reduce boilerplate. So especially because I don't have inheritance now, I can infer these fields that they can be removed, right? So what I can do now is do qtrim, and as you can see now, it started removing a bunch of fields. So there's very often now only one field left in a struct. So I have the simplify option, and it simplifies it even more. So if I go to, just so you know, because I based it on this template, this is now a general thing. You know, like you see that a lot of these services, they have been reduced. Some of them even quite considerably. So we've managed that without even touching any of these files, we've reduced, I can tell you, about 900 lines of Q just by copying this one template. So what you can also see here is that a lot of the deployments have a service. So I don't have time to show that, unfortunately, but you can also imagine that I define like a comprehension where I say for every deployment that I have, I want to have a service where any exported port is included. And then if you do that, there is a tutorial online which shows this, then these service entries will disappear as well. Yes. So, so what I've shown you so far is that I've extracted a top level, if you will, template or schema for Kubernetes definitions. But what I've also shown you, this is often in practice not enough. So I want to have like more specific constraints. So you can imagine that Kubernetes themselves define a lot of constraints, and have validation checks on the values you provide. So wouldn't it be great if I can also use these same constraints in Go code that you also use to generate templates or to generate anything else? So I don't know if you guys are aware, but Kubernetes uses Go as the source of truth. So basically, even the protocol buffer definitions are generated from Go code, not the other way around. So it would be really nice if you could annotate the source code with additional constraints. So this is a new package. This is not checked in yet. Everything you've seen so far is checked in. This is not. But with the kubego package, basically what you can do is you can add constraints to Go code. And it actually makes it much easier to check constraints as well. So here you see I have a sum type with A and B and C needs to be the sum of A and B. I can encode it as a constraint. And if I then call complete, if I have an underspecified constraint, it will fill in the remaining values. If the constraints don't match, I will get an error. So I can do this in a more general way. I can assign any kind of Q snippet to a type in Go. And then if I call something like validate, so in this case I'm saying the file name needs to have a JSON extension, min needs to be larger than 100 and smaller than max, and max needs to be smaller than or equal than 10,000. So in the example I give you a wrong file name and it will complain, right? So these constraints can get quite complicated, so if you have to write this out in Go code, it's actually quite tedious. So this is quite a new project. There's a lot of things to do. So things that people at Google are jumping for is protobuf support, and I think outside also. Kubernetes is moving more to open APIs, so this is a good thing to support. We need diffing functionality, testing functionality. If you test large code bases, why not data, right? And also I showed you how to reduce like your leaf configurations, but actually the known algorithms in this using this approach is going the other way around. So giving a bunch of leaf configurations, compute the templates, right, that can minimize my configuration. So this is something that I still need to add. And with that, I'm going to open it up for questions.
Thank you a lot. So questions? Yeah, we have mics for questions, so please wait until you get it.
Hi, thank you for your talk. I actually have a question about support. You mentioned that you plan to add protobuf and OpenAPI. Is there any plan for support? I previously mentioned HCL, for example. It will be great to support Terraform files in a similar way.
Also, so the problem is because you have work with types and values, right? Like there's many ways in which you can do support. Also with protobufs, do you want proto values, proto definitions? So one thing that is added, I just haven't tested it yet, but it is available, is so using Go templates. Right, so it's actually not that hard to write your own generation for pretty much any kind of language, but HCL would be an obvious one to support, right, to generate. So also even building on top of the whole Terraform infrastructure would be a nice one, or Helm, right? Like this can be used in conjunction with a lot of these things.
Yeah, thank you. And one question, is there any best practices, for example, similar to Helm, composability of charts? Is there, how can I compose for configuration in queue?
So this is a very good question. So one of the big problems in configuration is you have these two camps. It's like if I have my definition, right, my schema for, let's say, the JSON that Kubernetes accepts, am I going to expose this to users fully, or do I have some extraction layer where I limit it and basically have more validation? So the problem with the latter is that you're always fighting to add the new features to it, and it's never complete, and it gets out of sync quite easily. The problem with the former is with traditional languages is that you expose the full API and you have no control over it anymore as a template writer, right? With Q, you don't have that problem anymore. Like I can say you cannot use the template in this way, right? But still expose the full API. And then to come to your question, so one of the ideas that I got that led me to write this is I had my Kubernetes files and I really wanted to also generate Docker Compose. And what I want to do on the one hand is have some nice abstraction for the things that are relevant to me and generate Kubernetes from it and Docker Compose. But I still want all the features of Kubernetes at the same time as well, right? So how do you manage that? So with this is actually very easy to do. So I can add a Kubernetes section, generate everything, and then just merge that together. And because order doesn't matter, this will never result in a problematic situation as you would have with inheritance. So with inheritance, it's actually very hard to construct. In Q, this is one line, right? This is very simple.
Okay, thank you.
Yeah.
Hi, thank you for your talk. I have a question. Do you have some plans? Well, now we can validate against Go code, Go structs. Do you plan any other programming languages to integrate to Q, integrate validation with Q?
Yeah, so that's other programming languages. So right now, as it looks like, the vast majority of systems you would care about are actually written in Go. But there are some other systems. The problem is Go has very good tooling to analyze the language, and not all languages have that. If you have that, it becomes not so hard to implement. Like the code to analyze and Go code and split out the templates is about 500 lines or something like that. So it's not so hard to write, right? But you need to have good support from the language. So if you have that, it's doable. If you don't, it becomes difficult. Yeah.
So thank you so much. Applause to Marcel. Yeah. And so you have to choose your favorite question.
Well, I really like the API level. Like, where do you expose? That's a very good observation. So I'd like to give that question. Can I throw? Wow. All right.
Hey, thank you guys.
Yeah.